Okay, so we're back, and I am feeling a little under the weather, but I'll try to get through the remainder of this video so you all will be ready for class tomorrow just to work on some problems. And so here we're going to do this example where I told you that there could possibly be sort of a glitch in the method. But we're going to proceed accordingly, and then we'll see where this glitch turns up. Okay. And so here to get started, we know, okay, let's find the complementary function. So let's look at this auxiliary equation. M squared minus 5m plus 4 equals 0, right? And this factors m, minus 4, m minus 1. And so m equals 4 and 1. And so therefore our complementary equation y(c) of x equals what? C1 e to the 4x plus C2 e to the x. Okay. And so looking at now finding our y of p, y sub p, our particular solution, well, according to the table and how we would set it up, it looks like what? We would start off with y of p. I don't know why I don't just put equal signs. But a to the ex, right? And so let's look to see what happens. Well, we take yp prime, we'll get what? A to the ex, and we actually get a to the ex for all of them, right? If we were to take that and plug that in, we would get a to the ex minus 5, a to the ex plus 4a to the ex equals, well, we want it to equal 8e to the x, right? This is what we want. What happens to the left-hand side? It goes to 0, right? And that will never be true, right? That will never be true. So, what's happening? Well, what's happening is this. You know how we started off with a to the x? Well, if we go back, look at our complementary solution. It's really the same because if we let C2 equal A, right, whatever A is, right, it's A is representing a constant, C2 is representing a constant. So that term is in our complementary function or equation. Whenever that's the case, you'll always get 0, right? You'll get 0 if it's part of the complementary solution because the complementary solution is the homogeneous. It's the solution to the homogeneous equation or homogeneous equation. All right. So what we have to do when that glitch happens, and this is why I reiterated in the last video that you need to do the complementary function first because you need to figure out to make sure you don't have duplicates. And then if you do, you have to set up your particular solution accordingly. And so what that means is this. And this is in your book, The Formal Method. You can check it out and write down sort of the formal rules of this. But basically, you add, until the duplication is gone, you keep adding powers of x to that particular solution. So in other words, we're going to have to redo y of p as ax to the ex. Okay, and so let's do that. So y of p equals ax to the ex. And so y of p prime equals a e to the x, the derivative of the first times the second, plus the derivative of the second times the first. And then yp double prime, go ahead and double check this. Once simplified, you should get 2a e to the x plus ax e to the x. Okay. And now you can go ahead and plug it back in to your equation and do what we did prior. Okay, so I'm not going to try to make this video short, so I'm not going to go through all that. But when you end up your final answer, A should actually be negative 8/3. So your general solution then would be C1 e to the 4x plus C2 e to the x minus 8/3 x e to the x. Okay. Another way to think about it is remember your final solution, they should be independent, right? They should be independent of each other. So that's another reason why we can't have duplicates in our when we set up our particular solution. Okay, so in your notes, what I want you to do, I actually do want you to write down the form rule. It's called form rule for case one. That's the one we do just the regular, looking at the particular solution setup from this table right here, right? So I want you to write that down, and then form rule for case two. That's the new one if you have duplicates in your particular and complementary solutions. All right. And this final thing, and this is actually in your book, but this is just to give you a better understanding of how to understand that glitch. So this is example 7 in your book. I'm not going to do it. I just want to show you sort of the error, how to set up if there's a glitch, and really understand what that multiplication rule is. The second case 2 is a multiplication rule. That's what it's called. So it's actually called multiplication rule for case 2. And so this is an example, and they actually gave you, so the complementary solution, so it's e to the x, right? So normally, as long as there's no e to the x in your complementary solution, your particular solution would just be a e to the x, right? But in fact, your complementary solution is c1 e to the x plus c2 x e to the x. So in terms of that multiplication rule, the multiplication rule says if there's duplicates, right, you multiply it by x, but where xn is the smallest positive integer, that eliminates that duplication, all right? So that's a lot going on, but basically this is what this is saying. Well, I know that e to the x is in my complementary solution, right? So then that would tell me, oh, I'll just set it up as ax e to the x, tack on an x, right? But this second term is also in my complementary solution. So what do I need to do now? I need to square that, okay? And if by chance, if it was plus c3x squared e to the x, then this particular solution will become cubed, okay? So hopefully that makes sense. It's the smallest one that stops it from duplicating what's in your complementary solution, okay? So you guys are solid. You should be solid now. You may want to go back over the book for this section, but you should be able to do well on the problems from section 4.4. All right, see you all in class.